morning or afternoon, depending upon where you're calling in from. Um, I think some of you know me, but a quick introduction. Michael Gould. I'm a GIS professor, been teaching GIS for about 25 years now at a university in Spain. And I've been based in Spain for a while, but traveling around the world. And I've had the fortune to visit many of your universities in Eastern Africa and other countries. Um, I've been with Esri since 2009, and global education manager means that I work with the various Esri offices around the world, including Esri Eastern Africa. And through these Esri offices, we're able to reach out to more than 10,000 universities around the world. So it's been my pleasure to have visited about 400 universities over the past decade with my Esri hat on. So I've seen a few things, and I've seen what's working, what's not working, and it's my pleasure today to talk about this concept of modern GIS. And so I think you all have heard something about modern GIS. What we mean by modern GIS is moving away from traditional desktop GIS to a more connected world where we have GIS functionality available in our mobile devices, on the cloud, on servers, and of course, still on the desktop. And everything is becoming connected, interconnected, and distributed. So it's an exciting time for us. It can also be a challenging time at universities because I think some of us as instructors feel like we need to know everything and we need to teach everything. And of course, that's not the case. So I'll show you just a sort of a quick sampling of the directions in which the ArcGIS system is moving. And then I'll show a couple of quick demonstrations about sort of parts of the modern GIS ecosystem. And then hopefully there'll be plenty of time for questions at the end. What's interesting for us is that GIS is being applied in many fields around the world. And so, of course, education is one of these fields, supporting all the other fields and creating experts who can go and work in agriculture or who can graduate and work in the environment or in retail or in nature conservation, etc. All these areas that Esri supports are sometimes called industries. And so I would encourage you as educators or as students to visit the Esri Industries webpage, because the Esri Industry webpage allows you to have a look into what people are doing with ArcGIS in the business world or conservation or energy or defense and intelligence or architecture. And the list goes on and on. This is just a small sampling here. So this gives you an example of some case studies and some success stories in various parts of the world that are utilizing ArcGIS. My team would like to help universities better correspond with some of these industries to move GIS across multiple departments and multiple faculties at the university. Of course, we know that geomatics engineering, geography, and a few geo specialties are very, very avid users of GIS and now for many years, but we're seeing it spread across many, many other departments, the business school, public health, and many others. And so it's interesting for us to try to make this connection between what the university is teaching and what the industries are asking for with regard to the graduates. If we travel back 20 years, kind of through our time tunnel, this is when Facebook was just created. Some of our students were just being born. Mobile telephones looked pretty ugly and they were not very smart. And back in 1999, actually, ArcMap was created. And then ArcView came a little bit later. This is fairly old technology, and it's technology which still works. It's still functional. So we kind of feel like we're asking you to take your car, which is still running, your 20-year-old car, and tell you to scrap your car and buy another car. It's actually not the case. It's just that technology has moved on. ArcMap has served its natural life, but there's new technology that we hope everyone will move forward and start teaching and start utilizing. Certainly, the industry is doing that. So GIS has changed, and it's not just a shift from ArcMap to ArcGIS Pro. It's a shift from ArcMap, which was quite disconnected, to this new connected world, where our ArcGIS Pro is connected to servers and to the cloud and to our mobile devices. And we're bringing in drone imagery, and there are many, many different moving parts, and they're all connected. So this is something which is changing. I won't go through all this list of the changes, but I think you have a pretty good idea. To me, an interesting analogy is that my generation, if I was going to edit a document with a couple of co-authors for a publication, we would use Microsoft Word, and then I would take my text and I would send it as an attachment by email to my colleague. And I would say, okay, now it's your turn. You need to add some text. Well, of course, our students don't work that way any longer, right? Our students would go online and they would utilize the Google platform, or they would utilize Office 365, and they would all have immediate access to the same document online, anytime, anywhere, from any machine. And that's the direction that GIS is moving. And so increasingly, we have more sophisticated options for how we collect the data, how we process the data, and then how we serve out the data to multiple users around the world. Again, we're not expecting everyone to need to take a master's degree in GIS to be able to utilize geographic information. Now we have a few specialists like yourselves who are creating geographic information products and then pushing them out to mobile devices and to the web, et cetera, allowing non-experts to be able to ask simple spatial questions and receive answers from our system. So that's exciting, but also it can be a little bit daunting, a little bit complicated, because there are, as I said, lots of moving parts. So change looks like this: not merely making maps with GIS, but very sophisticated web maps and animations and three-dimensional representations, et cetera. Spatial analytics, spatial analysis is becoming much more powerful, and we're able to utilize huge data sets that we weren't able to touch before. Also, AI, of course, is playing a huge role in what we're doing these days, and I can just talk a little bit about AI today. I mentioned the mobile apps. I think you know about some of the mobile apps for creating surveys, or for not only visualizing data in the field, but collecting data in the field and synchronizing it automatically with the geodatabase. So there are many of our industries are out in the field every day collecting data. Think of the utilities companies, electrical, gas, water, et cetera. They've got potentially hundreds or thousands of workers in the field who are collecting data and feeding the data into the live GIS database every day. Down on the bottom here, imagery and remote sensing. I think many of you hopefully know that the ArcGIS system now has a fully functional, a complete image processing and image service to be able to create imagery products and then move them out to the masses. And then finally, sharing and presenting. So again, hopefully many of you know about creating story maps and dashboards and simple applications without needing to program. So this gives us the ability to take our geographic information products and turn them into something which is immediately useful by the general public, by the press, by your city mayor, et cetera. GIS actually hasn't changed with regard to the basic things that we want to do. We want to collect data regarding our world. We want to visualize the data. We want to analyze different data themes to see how they interact. But then we want to make decisions and want to take action. And so this is kind of a circular process. After we've taken an action in our city, for example, then we want to continue the cycle. We want to collect data again about our new city, and then visualize and analyze, et cetera. And so this cycle, this kind of geographic approach never ends, and that's exciting for us. As I mentioned, GIS is no longer just sort of the hardware, the software, the typical diagram that we've seen in textbooks many years ago. It's now quite diverse, and now we're taking in data from other worlds. We're taking in data from the architectural, engineering, and construction world. We're creating building information models. We're taking GIS indoors, and we're creating indoor models helping us to navigate or to locate factory equipment or assets, et cetera. We're doing more with citizen engagement. So citizens can be out in the field collecting data and feeding the data into our GIS, and we can start taking into account their real-time and real-world data. On the left side here, smart measurements. And so the world of IoT, or the Internet of Things, connecting to thousands of sensors that might be measuring vibrations on bridges or temperature or traffic, et cetera. So this is very exciting for us to be bringing in all sorts of new data sources. And essentially, we're creating what's now being called a living digital twin. So a sort of a digital representation of our world. And so that's very exciting. Continuing here, I mentioned the web mapping and cartography, which is now quite sophisticated. So we're not just creating black and white maps with our north arrow and typical cartographic features. Now we're becoming much more multimedia oriented, 3 dimensions, of course, or 4 dimensions if we're considering time, and it's quite exciting. So we've got some rich data sets which we can show in various different cartographic ways. We can create antique looking maps, and we can really create some pretty interesting styles with our cartographic system. And of course, this is where we're moving. So not just static cartography, but being able to show, in this case, noise data, could be traffic data, could be any sort of real-time movement data. This is the kind of animated and real-time cartography that we're able to create and be able to expose to the general public. Again, this is not the traditional GIS. This is modern GIS. I mentioned spatial analysis, so the collection of spatial analytical tools within the ArcGIS toolbox keeps growing and growing. Not only traditional ArcGIS tools, but we're able to connect to the world of R for some more sophisticated spatial statistics, and we can link to R. We can bring that in as a new toolbox. We have new toolboxes for imagery. We have new toolboxes for AI, for geo AI, and so this is very, very exciting. And this collection keeps growing with each new release. In terms of imagery, we're able to look at not just single images, but we're able to look at animations of images going back in time. We've got access to large time series of imagery from, for example, Landsat and Sentinel, and I'll show you that in just a moment. And as I mentioned, imagery is not just utilizing an image as a sort of a background for our other geographical analysis, but ArcGIS now has full image processing and the creation of image products, pyramids of imagery, which allows you to sort of fly into the earth and then go down into various levels of detail and to manage large collections of data. So that's really interesting. And then, of course, as I mentioned, hopefully you know about creating dashboards, which are telling a story utilizing infographics, instant apps, the ability to create applications without needing to do any or much programming, utilizing a wizard to create applications for both mobile and web devices. And then down at the bottom here, story maps. When story maps came out many years ago, of course, the traditional GIS people thought, oh, it's not real GIS, and they were a bit skeptical. Now everyone is crazy about story maps. And people have learned that not only do we want to publish our results in a typical academic journal, but we want to also take our results and put them into a format, a multimedia format that the general public can understand, that our city mayor can understand, that our university president can understand, or that the press can grab onto and can talk about our research. And so that's been very exciting. And so story maps have taken off. This is just one example. I won't go into too much detail here. Regarding the mobile applications, again, our field workers are collecting data and are doing GIS analysis utilizing their mobile devices every day. This translates to field work in the research sense, or even classrooms, taking our students out into the field and collecting data and doing some analysis in situ. What I'm not showing here, of course, are flying UAVs and taking giant point clouds, collecting giant point clouds, or ortho images ortho imagery. All these things are possible. We bring in the data from our in situ world, and then we can analyze them back in the laboratory. And so we've got many, many different mobile workflows. So this is an important part of modern GIS. Again, getting away from the desktop and moving to the cloud into mobile devices, and kind of determining for each particular research topic or for each particular classroom setting, which combination of these different pieces do we need? When is it appropriate for us to go out into the field and do some mobile GIS? When is it appropriate for us to be mapping with UAVs? When is it appropriate for us to be moving our research up to the cloud and utilizing large clusters of computing capacity? Everyone's interested in AI these days. I should say that from our master's students who come through from various countries, including many countries from Eastern Africa each year, probably half of them now want to work on some sort of AI for their final capstone project. Esri is offering two types of AI capabilities. The more traditional one is this GeoAI capacity, allowing people to do things such as extract features from imagery, training our system to be able to recognize rooftops in different settings. Of course, rooftops in a particular village in Africa will be different from the rooftops in Australia. We can recognize trees, cars, all sorts of different elements. And we publish the models which are utilized to do these classifications, and we make them freely available. So you can download, you can access, utilize, but you can download these models and you can retrain them. So if you find that something's not working, just quite right with your type of vegetation, or with your type of traffic patterns, et cetera, then you can take the model, which has been produced and published by Esri, and you can retrain it. You can do what's called reinforcement learning to add extra information to make it more relevant to your particular site. So these are the pre-trained models that I've just mentioned. If we visit the Living Atlas of the World, which I'll show in just a minute, the Living Atlas of the World has not only static data sets, it has giant imagery collections, it has access to real-time data services, but it has access to more than 70 of these pre-trained models for deep learning. And again, this is for extracting features, et cetera. So this is one type of AI, the GeoAI. Another type of AI that Esri is rolling out with the next sort of few versions of our software are assistants, which will help you to utilize the software. So we've already got, for example, an assistant which allows you to create a survey 123 survey. So it asks you a few questions and you tell the system what kind of survey you'd like to create, and then it creates it for you. Another example is that we've got some demos online showing how we've got some assistants helping our users to source data, to find the right data sources for particular GIS analysis. And it helps us to find the data sources in particular catalogs and in spatial data infrastructures. So that's interesting. That's more the generative AI, and that's coming in our future, and that's very exciting. We know that many of our students would like to become programmers, or at least have a little bit of programming on their curriculum vitae. There are many opportunities. I think you know that in the past, Esri had specific Esri languages, and that was maybe a little bit uncomfortable for the general purpose programmer. These days, everything is in Python, or for the web in JavaScript. So there are many, many Python programming examples and tutorials, and we can utilize Python within the Pro environment or within Jupyter notebooks. So there are many, many different ways to utilize Python programming. And of course, I mentioned JavaScript as well. So we've got all sorts of tutorials and examples for taking the JavaScript API, for example, and creating very, very engaging GIS applications for the non-expert. I mentioned R, I mentioned the bridge, which has been created such that we can expose the entire R collection of functionality as a new toolbox within ArcGIS Pro. So that's exciting. So I mentioned the Living Atlas of the World. Hopefully you are familiar with the Living Atlas of the World. For many years, Esri was not a data company per se. We were telling people we're a tool company and we're agnostic to the data. You find the right data, we can help you to process those data. Well, increasingly, we've been bringing on board more and more data sources, and now we are essentially a data company. And many of these data sources are freely available on the Living Atlas of the World. This is perhaps the world's largest collection of curated geographic information in the world. So many, many ready-to-use base maps and layers. And as I mentioned, not only static layers, but also access to real-time data, such as for traffic or for weather, just to give two examples. Loads of imagery, and I'll show a couple of examples, lots of place names and demographics, and it's a rich collection of data. And this is allowing many of our users to jump straight to the use of analysis-ready data, ARD. Many of our users do not want to spend all of their time starting from scratch, creating data sets and cleaning data sets and reformatting data sets. Many of them would like to be able to jump straight to getting access to land cover, or getting access to highways, or getting access to elevation. And we have many, many of these fundamental data layers readily available for analysis on the Living Atlas. The Africa Geo Portal is in a sense, a kind of a subset of that Living Atlas. So the Africa GeoPortal is a free portal, a free site for you to visit, become a member of, join the community, get access to software for certain training purposes. And we use the Africa GeoPortal all the time for certain initiatives, such as if we're going to run a hackathon with a particular group, we'll say, okay, come to the Africa GeoPortal, register yourselves, and this is where we're going to centralize the hackathon. Here's where we're going to provide your data sets. Here's where we want you to submit your final results, and we can kind of centralize things there at the Africa GeoPortal. And so this has a nice data collection as well, which is, again, a subset of the Living Atlas. You can contribute to this, and we encourage you to contribute your fine data sets to the Africa GeoPortal. So if you think you've got something which is complete, which is properly documented and everything, which can be readily utilized by others in the community, please do submit them or contact us so we can help you to get that ingested into the Africa GeoPortal. So summarizing here a bit, the ArcGIS system is now becoming so diversified and so complex that we feel like some educators and some students are a little bit maybe confused or a little bit hesitant to jump forward because there are just so many different options, especially when the university has access to an institutional license. And we'd like to make institutional licenses available to all universities if possible, because this allows everyone at the university, no matter which faculty, school, laboratory, to get access to all the tools that they need. The question is, which tools do we need? And this I liken to the breakfast buffet. If you're able to go to a nice hotel, you come down for breakfast, and oh my gosh, where do we start with breakfast? At home, I will have a bowl of cereal and a cup of coffee. Now suddenly I have 105 options. Where do I even start? Well, that's our job. So my job and the job of our our education team is to help you all decide, for this particular teaching purpose, which tools do we need to use and which methodologies, which data sets. For this particular research project, which tools, methodologies, data sets do we need to use? We can help you with that. We can help to guide you. And it's not necessary for everyone to think no one at our company knows everything regarding the Esri platform. It's just so diverse these days. So part of our job, again, is to help you to determine which are the necessary tools and methodologies. We also have many learning resources to help you to find your way through this jungle of options. So we've got e-learning and the MOOCs, the massive online open courses. Hopefully you know about those. There's another interesting one coming up in a couple of weeks. There are lots of online tutorials and learning options, Esri Press books, et cetera, et cetera. Mentioning the MOOCs, the cartography MOOC is underway and about to finish in a few weeks. So hopefully some of you are participating in that. The GIS for Climate Action MOOC is coming around again. It was held about 6 months ago and it's back. So this is Don Wright, our chief scientist, and a bunch of other experts who are leading a 6-week course on GIS for climate action. We've got some really interesting online tutorials there showing you how to do various things with various data sets from around the world. So that will be starting on May 1st, which is just in a couple of weeks. So we hope you'll all sign up for that climate MOOC. I'm going to jump out here and hopefully show you a couple of websites. Let's see if they're going to cooperate for me. So hopefully you're seeing a website. Can someone confirm that? All good, Victor?
Yes.
Yes, Mike.
Okay, so
I can see the screen.
Okay, so here what I've done was I've come into the Living Atlas, and I can maybe try to click back here, and I hope it's not going to interfere with anything. Seems like I've got a performance issue here on the web. Within the Living Atlas of the world, we have many applications, such as this, which is called the Land Cover Explorer. So this allows me to go around the world. Here I'm looking at Zanzibar, and I have visualized a land cover map of the globe, which is created between Esri and Microsoft and some other partners. And this is a 10-meter resolution land cover map. And let's see if I can get the browser to respond here. Because what I would like to do is I would like to zoom out. I guess I need to stop the animation. I'm sorry about that. So I'm not getting a response from that. Let me look at this one. Okay. This is another of the explorers. This is the Landset Explorer. So we can kind of drill into Addis Ababa, for example, or any place. And what's nice about this is that this gives me access to the entire collection of Landsat imagery back to 1982. And there have been renderers here on the bottom right, which are created, which are going to render my viewport wherever I decide to zoom into on the fly. And I can click here on natural color, and let's see how fast it's going to be on the web. A little bit slow at the moment. So there's natural color or shortwave infrared or NDVI. And so what it's doing is it's reclassifying this image for me on the fly. The server is doing this for me, right? What I'd like to use this for is we've been doing a lot of extreme heat mapping lately. And so I can get access to surface temperature for any place on Earth. This is coming from band 10 of Landsat. And I know I can go anywhere. So I can go to Mombasa here and I can have a look at the surface temperature. See if it wants to react here. And I can go back and I can find a scene. I can go back years and years, and I can go back and I can find particular scenes. And it's telling me here that, for example, for the month of October, I've got a Landsat 9 scene with 72% cloud cover. That's not interesting. 39% cloud cover, not too bad. 37. Here's one with 28% cloud cover. So I can choose one of these. And if the system wants to react, there we go. I've got access to that image. And I can go later on into Pro or into the map viewer, and I can get access to these same images and I can bring them into my analysis. So that's something we've been doing lately. In fact, let me click over and show that. So here's the industries page I talked about before. So, I mean, just to grab one example here, if I want to look at agriculture, it takes me to that sort of world and shows me what's going on regarding agricultural uses of ArcGIS. So there are many, many different industries that you can explore there. I should mention that we have a website which is aimed at this very topic that I'm covering today, which is modern GIS in higher education. So if you were to search on Esri modern GIS education, I think you'll find this pretty easily. And so this talks about different curriculum materials and this sort of some success stories, some case studies, etc., pointing you to particular curriculum items. So we've got a whole website set up for people who would like to move a little bit further down the road towards modern GIS. And people who are maybe wondering, how can I do sort of modern cartography or imagery or scripting or mobile GIS, etc. So we've got a lot of learning materials there. Here I'm in the Living Atlas. And so in the Living Atlas, we've got, as I mentioned, thousands of different data layers. I've searched here for Landsat level 2 because I know that this is where I'm going to be able to get access to that entire collection of Landsat imagery going back to 82. So I can open that up in my map viewer, or I can open it up in Pro, or I can open it up in one of my applications that I've created in JavaScript, for example. And so here's all my Landsat imagery. And this is probably the most recent collection. But I can go through here and I can say that I would like to bring up a processing template, which again this is this on-the-fly server-based reclassification. And I can say, okay, I want to have a look at the recent images and I'm looking for surface temperature in Celsius. So hopefully this will be reactive here. It won't take too long. There we go. And I can kind of zoom in to Mombasa or wherever, and I've got access to my 30-meter pixels regarding land surface temperature. And I can go in here and I can say that I would like to add a little bit of transparency, and I would like to bring up a base map, and I'd like to overlay that surface temperature on sort of ordinary imagery. And that allows me to slide back and forth with transparency and have a look. Or I can say that I'd like to look at it on top of OpenStreetMap to give myself a little bit of context, right? And of course, OpenStreetMap is irregular, so some places have lots of information and some places not so much. Zoom into an airport here, and we can have a look at the surface temperature when that system catches up. Here we go. And so this is an active analysis ready data layer, access to the Landset imagery. And I can do the same with, I think I've got an example here. Let me move this, got something in my way here. Here's another layer. I brought up land cover. And this is also Mombasa. So I've got land cover coming from the European Space Agency in 2020. This is a 10-meter pixel. So I'm able to go anywhere on Earth and kind of zoom in and have a look at land cover. And again, this is a data layer that's ready to go. So if I want to ask, who are the vulnerable populations in my particular city who do not have tree cover, I can pull tree cover out of this land cover, and are in an area of high surface temperature. I can pull the high surface temperature out of Landsat. So I can bring these three different data layers, my demographics and my land cover and my land surface temperature from Landsat. I can bring that together immediately and start doing my GIS analysis. Now, this is a pretty amazing way of working. Just a decade ago, we were always struggling to find data, and it would take us months and months to be able to get to this point where we can overlay our tree canopy cover with our land surface temperature, with our demographics, and ask a very simple question: who are the vulnerable populations who are affected? That's very, very powerful. And again, this is because Esri is hosting this analysis ready data and it's ready to go. So I had some other examples here. We've got a series of blog articles talking about how to create one of these heat indices, one of these heat maps. And it's basically saying we take surface temperature from one image, we take tree canopy cover from another image, we take our population from world pop data or from your census data, depending on where you live. And then we put these three layers together and we weight them and we create an index. So which are the areas that are more susceptible to extreme heat or less so? So it's a three-part series. So here he's talking about extracting the heat data, in this case from Seville in Spain. Part 2 is how to extract the tree cover from that other image that I showed you. And then blog 3 talking about how we get our demographics data and then how we mix them together and we do our analysis. So this is the modern GIS way of working, getting access to this analysis-ready data. Those examples that I showed are part of a curriculum collection or a tutorial collection that we have within Learn, arcgis.com. And so this is a climate resilience curriculum. It's a whole series of different pathways where we can look at sort of urban planning, or we can look at community action or natural resources. And we've got a whole series of lectures and data sets and things there. I mentioned AI, and here's just one example where we've taken the model from Meta called Segment Anything, which was being utilized to segment, for example, from photographs, identify the cats or identify the cars or whatever. We took that same model and we applied it to satellite imagery, and we were able to extract features. We're able to train the model to look for planes or look for round objects that might be water tanks, etc. And so there's a video here showing how that's being done using that same model. Here we're looking for a particular type of house that has a particular architecture and a particular geometry. We're able to pull those out of the imagery very quickly and very, very efficiently. I mentioned drones. We fly drones not just to collect 2D imagery, but we fly drones, so we're able to have a look around at three-dimensional imagery and point clouds and do some pretty spectacular things and get some very high resolution images of particular landforms or architectures, et cetera, et cetera. So I think I'm going to stop there. But this is giving you a little bit of a taste for some of the new directions. And I do want to save plenty of time for questions. So let me stop sharing here. And Perhaps, Victor, you can help me with some of the questions, because I'm seeing maybe there are some questions that I'm not seeing while I'm doing my demo. I'm seeing a few comments. Was it the case that some people weren't seeing everything I was showing, that things were kind of stuck? What do you think, Victor?
One of the questions I think I was seeing is we have Zakaria saying he needs the PowerPoint presentation if it can be availed.